Hello, everyone. Would love to just first say thank you so much for having me here. I've just been so inspired from the first day I walked in, and having the conversations and the brain trust we have is just so phenomenal, and I just been inspired. Would like to talk to you about Safire and some of the technologies that we've been building. At Safire, we understand that legacy energy systems cannot power the AI era. What we're seeing in today's energy usage from what we have been seeing before is very different. And especially on the battlefield today, so the commanders would ask how much ammo is required to win, but now they're asking how much energy is required to win. And energy has become now an area of focus where if it's centralized, then it's a focus of attack, and it is really important for us to defend our energy systems. The future is AI energy intelligence, and that's both in hardware, advanced chemistries, as well as software. So at Safire, we have developed a Tempest, our core stack. Our core stack is all the way from energy systems on the battlefield, where we are able to understand and have energy battery systems that we've developed, where it is able to go out onto the field and have that energy information be sent into a common energy picture. It's the energy layer that was missing today, and being able to bring telemetry data from all of the new assets, including drones, unmanned ground vehicles, other systems, into one layer in our command and control systems is a technology that doesn't exist today. Safire Bolt is a way that we are able to do this, not only in our own battery systems, but it's asset agnostic. So working with some of the partners, we're able to bring out their technology information into our software so that the commanders can make the best decisions. Safire Storm is a communications layer infrastructure, a mesh, where we can do this in the most secure way. And Clear is our chat application where we're able to communicate between the user and the users to user, but also to user to software in the ways that we are using now, Claude Copilot, or some of the Copilot opportunities as well. And our EOS is our flagship software where we're able to bring all of this in an AI-enabled way for the soldiers on the battlefield. When we realized with our software, and we are working with the Department of Defense, they are now asking us to put this into systems out on the battlefield, but also at their headquarters. But in the recent year, we have been pulled into helping with AI data centers in the enterprise and commercial sector. The same goes for data centers, where they want to understand from the grid usage, from the globe perspective, and how the grid is being utilized, and understanding the external factors into their data centers. So we're able to understand that across the globe, here's all the data flowing, and how much of it is being utilized inside the data center, but also within the data center, how much of it is being used across different types of servers, firmwares, GPUs. And having that living and breathing intelligence is very, very useful, not only for predicting spikes such as hot weather coming in or AI spikes, but also being able to understand where there's redundancies and ways to proactively work on these problems and not reactively with just alerts. Our core hardware stack is a requirement that we have worked with Air Force and Army Special Operations Command, where they want to have a battery system, and when they bring the battery systems across different islands or different places, they're able to bring these batteries together and have these batteries automatically sense each other, so that when you bring 10,000 of these batteries, you're not just having 10,000 individual batteries, but it acts as a microgrid and tactical grid. And the ability to be able to have energy usage and energy storage systems that's mobile is so critical, because as we have it in one centralized location, then that is where we will get attacked. And when we lose that, we're having all these conferences I go to around AI, and they're doing all this mathematics and algorithms in the battlefield. But at the end of every conference, they say, without energy, there is no AI. So we must have a resilient energy systems, and that's what we are building for defense and critical enterprises. Our traction is across the board with Air Force, Army, and Space Force, where we are making advanced chemistries inside the battery cells that can survive Arctic environments. We're also making a silicon nanoparticle out of Oak Ridge National Lab, Department of Energy, where these particles will prevent batteries to survive launch and re-entry into space, so that these batteries can be transported in a SpaceX Starship. As well as the software and the ISU container on the smart energy technology that can be slinged on a Chinook and can be then moved around from island to island and from different continents. Thank you. That's right.
Thank you so much for having us over here today. Thank you to Matt and the ever wonderful leader, Wildcat Trammell Crow, for always getting this going. I think it's in its 15th year here at EarthX. I am very happy to be back in Dallas. Absolutely love to enjoy my time here. And as you've already heard the start of with John and what he's focused on, why don't we go a little deeper dive of what brought you here to EarthX and how it is focused within the islands?
Yeah, absolutely. Public-private partnership, what I call a PPP, is so important. And it's rooms like this where we have world leaders in both government and enterprise, but also that are folks that are moving around capital to come together. And it's rooms like this where we're able to have those conversations very directly and to share what we're working on. And just cross collaborating between, even just looking at some of the technologies that I've been working on the defense side and how that can be utilized for the commercial and enterprises across different types of ways in which we can save and help Earth and save on energy. It's just super important. So really, really happy to be here to meet and be able to find partners. It's going to take all of us to bring new technologies to life, it's thought this would be the best place to be.
Yeah. Earth is a team sport. It's true. You describe Safire as a platform, not a product. We'd love you to go a little deeper with that now.
Yeah, absolutely. What we realized at Safire is that we were first born out of Oak Ridge National Lab at the Department of Energy. That's where some of the first nuclear materials were invented, nuclear reactors were invented, and we were working on the advanced chemistries. And we're working on the silicon nanoparticle to prevent batteries from blowing up when it gets in a hit, such as in the EV car. And we are also working on ultra-low temperature battery cells that can survive negative 60 degrees Celsius. But what we realized is that there will be new chemistries, and I've met many other energy battery companies here that's working on some of the best chemistries from a physical perspective. But as those come online, we actually need software. It's not just hardware and chemistries, but the reason why, and you might be surprised at this, the reason why iPhone survives longer now is not because it has a cooler battery. It's actually because it has much more sophisticated software. So that way, it's actually killing off the apps that as you're not using them, and it's lowering the usage of the processors. And so at Safire, we realized, okay, let's not just do chemistries, but let's just build out a software team, AI team, to unlock some of the most advanced technologies and make our batteries modular, so we can embed software and PCB board designs and battery management software inside the batteries.
Safety and reliability. Why are these binding constraints on global electrification? And I don't know if you have, I've been able to do some long stretches on some islands. And as special as it is to be out in the middle of the ocean, it's such a unique feeling after being in large land masses. You don't always have access to everything. And especially as we've talked about this today is when there is an emergency, but also not wanting to be shorted. And as we don't want these islands to be caught behind by lacking energy with the computer developments.
Yeah, absolutely. It's actually a very similar use case that we were thinking about for natural disaster relief for defense in the case of islands as well. If there is an impact to an island, we want to be able to move energy from other islands to that island. And right now, that is very difficult to do, very costly, and also the technology doesn't exist to be able to do so in a quick manner. So we have been working on ways in which we have a mobile energy storage systems that can actually be hooked into a helicopter and then slinked to another island. And so energy is going to be utilized for the most the basic needs, and without energy, the safety and the health of the folks there is going to be impacted. So we wanted to make sure we're able to do that on both defense and commercial spaces.
Where is Safire already being deployed?
Safire is working very closely with U.S. Army Special Operations Command, and they are utilizing Safire software for before going on mission. They're using it for mission planning, so they can say, "I'm going to bring all of these equipments and systems, put into their Android. It's called an ATAC, an Android tactical phone. It's attached to everyone's soldier's chest, and they can put it in. It'll tell you how much battery you need, and that way you're not taking too much battery with you. You can save some for others." And as well as with the Operational Energy CIF, OECF group, they're also using it in terms of planning for, not just for batteries, but when we show them our common energy picture, they say, "Hey, can we actually see a common power picture? So let's actually bring together the logistics supply chain people of oil, jet fuel, and batteries into planning it out in terms of a new forward operating base or a new area of operation." And so that's what they're using it for that purpose. And then lastly, is actually the real-time pulling in data from when they're actually deployed in both the battlefield, but also in data centers, understanding the energy flow within the data center, where it's going into each specific rack and server, and then understanding external factors such as hot weather coming in or different kind of natural disaster happening, to be able to distribute load across not only within the building, but also across a campus of buildings.
Excellent. How should governments be looking at partnering with Safire? Could you walk us through a little bit of that?
Yeah, we've been working very closely with the Defense Appropriations Committee and the Energy Committee, and we really look at it from the lens of what is needed for what's happening today. So right now, the ultra low temperature battery cells is something that they direly need. It's an area that we're operating in, and these batteries are dying, and which is quite bad. And so we made technologies not only to survive within the cold temperatures, but also just be able to heat it back up, have automated systems to make sure it doesn't get too cold. And so these are the areas that they're funding with us right now.
Great. What does strategic long-term capital deployment into electrification look like in practice?
I think it's really important for the capital side to understand what's coming up in the future. And seeing it. So the fact that there is going to be many new AI data centers, it's something that some of the capital investors have seen it early ahead. And so being able to invest in a long-term way, but proactively and looking in the future is one thing. The next thing that we're looking at right now is AI data centers in space. So there are data centers being built size of a stadium that will be shoot up in space. And so those kind of capital investments, looking at technologies around deploying that, logistics within space, the repairing, maintenance of in space, are all the areas that I think from a VC, PE, and investment perspective, we used to look at it from a manager perspective.
I love that. I got to point out the size of a stadium being shot up in space. Amazing. What does the infrastructure landscape look like in 5 years? Walk us to the future.
Yeah, and similar to thinking about the AI data centers, it's really interesting times for infrastructure. I think there's going to be a lot of, we're seeing it now, a lot of new chemistries of technologies that can bring more energy. It's the ability to have mobile energy. It's also the able to have more intelligent metering. There was a captain in the army where he went to like 20 different bases and then actually made a little tool and hooked it up to the lines, and then try to gauge how much energy is being used against energy bill, and guess how many times the bill was correct against how much energy was being used. 0. and we're just kind of and so we need new technologies to better understand the energy, energy saving it down to the oil prices going up just in the last 60 days has us thinking about, okay, actually batteries were kind of like just as a backup, at an AI data center, just in case something happens. And there's a very small battery inside every single server where you can then charge the batteries for 3 seconds. All of a sudden, oil price goes up, and every blueprint of the data centers It's actually kind of wrong now. Now the batteries are sexy again. They actually need a lot of batteries inside every single server to have a farm of batteries that's modular, so that when the prices go up, then it can actually utilize the batteries for charging up the data center. And when the prices go down, then charge the batteries again. So these types of new technologies in energy will save 1%, 2%, 5% across the globe, and that's going to change the world.
Fantastic. Well, thank you for coming out here today, and thank you everyone for listening, and so happy to be invited back to EarthX in Dallas, Texas.
Thank you.
And the island states.
Yes.